Hi friends, in today's lesson we are learning a little bit more about effects of the tilt and revolution of the Earth, and so we are exploring the question, why does daylight change? Before we begin, we need to review a little bit about what we've learned so far. So far we've learned that the Earth's tilted axis is what gives us seasons, and that's because heat energy from the sun is unevenly distributed in each hemisphere. And because it's unevenly distributed, that means there's a difference in seasons between each hemisphere. When the hemisphere is tilted towards the sun, it's receiving direct heat energy, and this gives us summer. That's the season that hemisphere experiences. When the hemisphere is tilted away from the sun, it's receiving indirect heat energy, which gives us winter. And then when there's the hemisphere is neither tilted towards nor away, which is really when it's moving from summer to winter or winter to summer, the Earth is receiving equal amounts of heat energy, but it's also increasing or decreasing on that journey too. So that's either fall or spring. Another part of the equation for seasons is that the Earth revolves around the sun. And because we're revolving, we're moving while we're tilted, and getting differences in seasons, we also see the seasons change. So the tilt is why we have seasons in the first place, and the revolution in combination with the tilt is why those seasons change. Another effect of the tilt and revolution of the Earth, though, is that we had to get different angles of sunlight throughout the year based on the tilt. And the changing angle of sunlight will cause the length of our days to change throughout the year too. And here's how that happens. This is an image of the sun's tracking in the sky in the northern hemisphere. So keep in mind, this is north hemisphere. It would be opposite for months in the southern hemisphere. But as you can see, the sun it appears to rise in the sky lower, so it will be sitting on the horizon lower in the sky in January for us, but this is winter time for either hemisphere. And then as the Earth becomes more tilted, the sun appears higher in the sky. And if it's appearing higher in the sky, this means that it has to rise, quote unquote, higher in the sky, which means it has a longer time to set in the sky. And that means we have longer days if it's up in the sky higher. And so that also means, going back to winter, if it's lower in the sky, we are going to see certain characteristics. And we'll talk about those in a minute, but the main reason is because the angle of the light is lower, so that energy is being dispersed over a larger area. And when it's higher in the sky, it's a more direct angle, more above your head, and all of that energy is over a smaller area. So it's the same amount of energy in either case, but when it's over a smaller area, it causes warmer temperatures. It's more intense. And then when it's over a larger area, it's less intense. And here's how that plays out in the characteristics of our seasons. So whenever it's summer, meaning the Earth, that hemisphere is tilted more towards the sun, we see, because of that angle of light being more intense, greater, we see more direct light, or the most direct light for summer. Then because of that, we get warmer temperatures. And because the light is in the sky higher, or the sun is in the sky higher, we get longer days and shorter nights. The opposite happens in winter when the Earth is tilted away from the sun, or the hemisphere is tilted away from the sun. The angle is lower, so we get the least direct light, which leads to cooler temps, shorter days, and longer nights. As we continue that revolution around the sun, we see changes that happen throughout the year. So whenever it hits to fall, the angles actually for fall and spring are a little more even. So whereas with summer, they were more exaggerated, as we move to fall and spring, they're going to kind of meet in the middle. And depending on which hemisphere you're in, if it's fall, you'll get less direct light, so less than what you had before, which will lead to decreasing temperatures over the season, which means your days are getting shorter because the sun is moving lower in the sky, and your nights will be getting longer. And then the opposite happens in spring. Because we're moving towards being more tilted, that means you're getting more direct light each day, which means you have an increasing in temperatures throughout the season, which means your days are getting longer because the sun is higher and higher in the sky, and your nights are getting shorter. Then, as we continue our revolution, it flip-flops, and the opposite season experiences those same characteristics, and as you can see, the angle of light changes. And it continues to change throughout the year as the Earth revolves around the sun, and the hemisphere is either tilted towards, away, or it's moving towards being tilted towards the sun, or moving away from being tilted towards the sun. So pay attention to the tilt, and just understand that the tilt and the direction of the tilt, whether it's towards the sun, away from the sun, or neither, it influences the angle of light, and that angle of light influences the characteristics we see for each season. That's the gist of it, and I leave you with this one thought. So this is actually another effect of the Earth's tilt and revolution that we aren't really digging into. This is a 24-hour time lapse of the sun's movement across the sky in a specific location. And as you can see, the sun never sets in this image. There are 2 places on Earth where the sun never, quote unquote, sets for a few months at a time. I put that in quotes because, the sun doesn't move, we move. So I want you to think about where on Earth are these 2 places and what times of year would they happen? Let me know if you come up with the answer.